Hello viewers, how are you? Today, once again, I welcome you on your own YouTube channel Learning Maths, and in today's video, we are going to discuss a topic from class 9th, chapter quadrilaterals, and in this video, we are going to discuss midpoint theorem. Hope you'll enjoy the video, and this is my request, please watch the video till end so that you can understand the concept very well. So without wasting time, let us start the video. So our first question, what is midpoint theorem? Let us see what is the midpoint theorem. You can see in this diagram, we have a triangle ABC. So let us see what is the statement of the theorem. The statement is quite simple. In a triangle, the line segment joining the midpoints of any two sides is parallel to the third side and equal to half of it. So in this diagram you can see, in triangle ABC, D and E are the midpoint of AC and BC respectively. And this DE line segment join the midpoint of AC and BD, then we need to prove that this DE is parallel to AB and half of it, because midpoint of two sides, this BC and AC, and actually triangle have three sides. One is AC, other is BC, and last will be AB, and we need to prove this DE will be parallel to AB. Now let us see how to prove this. This is quite simple, and we will use the property of parallelogram. So you can see we have a triangle ABC in which D and E are the midpoints of AB and AC respectively. So what we need to do, we will draw a line which is this CF parallel to AB. You can see in the construction. So first, what is given? Triangle ABC, AD is equals to BD and AE is equals to CE. And to prove DE, this DE parallel to BC, construction, draw CF parallel to AB and produce DE to intersect CF at G. So now in triangle ADN CGE, ADE CGE lines are parallel. So angle DAE is equals to angle GCE. Alternate angle, because Z forming angle, these are equal. Angle AED is equals to angle CEG, vertically opposite angles. And now one more thing you can write, and
AE is equals to CE.
Given. Therefore, triangle ADE congruent triangle CGE by, you have studied in the previous chapter, congruency, 7th chapter, by angle side and this angle. Angle side angle. So after that, what we need to do, we will write some CPCT. Hence, this DE is equals to GE by CPCT, and this AD is equals to CG. CG by CPCT. Now we come to here, this AD, but AD is equals to BD, therefore BD is equals to CG and BD parallel CG. Therefore, BCGD is a parallelogram. Hence, this BC parallel DE. So our first part is done. This DE parallel BC you can see this first part is done. DE parallel BC. Now we will come to the second part. So for that we will use this first result. Let us see how to do this. After this, now we come to the second part. We need to prove DE parallel half of BC. Parallel we have already done this. Hence DE parallel BC. Parallel BC. Now we come to the second part. Now DG is equals to BC, opposite side of parallelogram. Parallelogram, and DG is equals to DE plus EG is equals to DE plus DE, because this DE is equals to GE we have already done here by CPCT. So we have twice DE is equals to this DG, but you know DG is equals to BC, therefore twice DE is equals to BC, or DE is equals to half of BC. So this is the proof that in a triangle, if a line segment DE joins the midpoint of two sides AB and AC, then this will be parallel to this third side which we have done here, and this is equals to half of this third side. So D is equals to half of BC, we have done it here. So this is quite simple proof. Hope you understood how to do. Now our next topic is converse of midpoint theorem. This is just opposite to the theorem which we have discussed just now. What is it in this? You can see the statement, the line drawn through the midpoint, suppose this D is midpoint of one side, D is the midpoint of AB of a triangle, and parallel to another side, and this DE is parallel to BC, then it bisects the third side, that means E should be the midpoint. So this is quite simple. You just write, we need to prove that this E is the midpoint. So you know from the midpoint theorem, let E is not the midpoint. We write let E is not the midpoint. Let it be, let F be the midpoint. Therefore now you have very well from the previous theorem, if this is midpoint DE, so BC parallel DE and DC parallel DF also. Therefore both E and F should coincide, both should at the same place. Hence E and F coincide. Hence E is the midpoint. So in this we have discussed, if a line segment through the midpoint of one side parallel to another side obviously bisect the third side, that means E will be the midpoint. So this is quite simple. Hope it is clear to you all, and in the next video we will discuss how to use these theorem to do the questions of exercise 8.2. I hope you enjoyed the video. If you like the video, please press like, and if you are new on my channel, subscribe, and don't forget to hit the bell icon. Thank you for watching. Bye bye, take care.